All right, for this deep dive in our database history series, we're going way beyond your standard records and tables. We're about to jump into the high-speed, high-stakes world of next-generation identity systems and really get into the weeds on the complex technologies that are building them right now, from the ground up.
And this quote, it just nails the paradigm shift we're talking about. We're throwing out that old idea of identity as just some static file sitting in a database somewhere. The future is a real-time fusion engine, a system that has to understand and connect a constant flood of completely different kinds of data, all at once.
So here's our roadmap. We're going to trace the evolution of identity just to see where we're coming from. Then, we'll pull apart the AI fusion engine and the wild new search methods it needs to work. From there, we'll see how it all operates in real time, building this massive identity graph. And finally, we'll step back and think about what this incredibly powerful new landscape really means for all of us. You know, to really get what a huge deal this is, we've got to rewind a bit. The whole concept of what identity even means to a computer has been completely transformed. We've gone from physical ink on paper to this abstract, interconnected universe built entirely on math. For decades, identity tech was, well, pretty straightforward. You had fingerprints, and you looked for a simple one-to-one match. Not too long ago, we started adding other things like faces and irises into the mix. But the leap that's happening right now, it's on another planet. We are officially in the era of multimodal AI, where all these different data types can live together and be compared in the same space, as if they all suddenly learn to speak the exact same mathematical language. And the core concept that makes all of this possible is something called an embedding. The best way to think about it is like a universal translator for data. It takes something incredibly complex and unique, the swirls in a fingerprint, the structure of a face, the actual meaning of a paragraph, and it converts it into a super long string of numbers. We call that a vector. And this vector, it represents the very essence of the original thing, letting a computer mathematically compare stuff that seems totally unrelated, like a photo of a face and a document that describes that person. So how do we actually create these incredibly detailed numerical representations? Well, that takes a ton of computational horsepower. And that's the job of the AI fusion engine, which uses these highly specialized neural networks that are custom built for different kinds of data. For anything visual, like a face or a fingerprint, the system uses a convolutional neural network, or a CNN. Its whole job is to scan that image and pull out the key spatial features, like the distance between the eyes or the curve of a ridge on a fingerprint, and then turn all those features into that numerical vector, the embedding we just talked about. But processing text? That's a whole different ballgame. For that, you use a transformer model. It doesn't look at physical shapes. It reads for context and meaning. It actually understands that CEO and Chief Executive Officer mean the same thing, so it creates an embedding based on that concept, not just the letters on the page. And this is where the magic really happens, the fusion. See, the real power isn't just in making these individual vectors, it's in combining them. A system can now mathematically prove a link between a fingerprint embedding and a face embedding, and then connect that to a text embedding from some related document. These connections, that's the key to everything. Okay, so you've got millions, maybe even billions of these super complex vectors. Now what? A new problem pops up. How the heck do you search through all that data efficiently? This problem basically demanded a completely new kind of database, one that wasn't built for finding exact matches, but for finding conceptual similarity. Think about it. A traditional database search is very literal. You search for the word apple, and you get results with the word apple. Simple. Vector search is a different beast entirely. It searches for things that are conceptually close. You give it one vector, and it finds other vectors that are its closest neighbors in this crazy high-dimensional space, even if those vectors came from completely different types of data. The secret sauce that makes this near instantaneous search possible is an incredibly clever algorithm called HNSW, which stands for Hierarchical Navigable Small World. It's a type of approximate nearest neighbor algorithm. So instead of brute forcing its way through every single vector, HNSW builds this multi-layered map. This lets it quickly navigate to the right neighborhood of similar vectors, kind of like using highways to get close to your destination before you hop on local roads. This is the exact same core tech that powers the massive AI search engines we use every day, letting them search billions of items in the blink of an eye. But here's the thing. This whole architecture, it wasn't just built for digging through old files. Its real, mind-blowing potential gets unlocked when you point it at a live, non-stop fire hose of information and make it work in real time. This is where streaming analytics gets really interesting.
You have models like YOLO detectors that can spot people and objects in live video. You have person re-identification networks that can track someone across a dozen different cameras. You even have gait analysis that can create an embedding from the unique way a person walks. Each of these systems is just constantly pumping out a new stream of identity signals. And this really marks a fundamental change in thinking. We're moving away from a world where an operator types in a query and waits for an answer. The new model is a persistent, continuous identity feed. The system is always on, always processing, and constantly matching new signals against that massive vector database as they happen. So what happens when you have this continuous stream of interconnected data points coming in 24/7? Well, you organically start to build something far bigger and way more complex. A massive, sprawling network of relationships that we call an identity graph. This quote just lays it out perfectly. Identity isn't an isolated record anymore. It becomes a single node in this gigantic interconnected web. Every single piece of data, a fingerprint, a phone, a place, a time, is a node, and the relationships the system discovers between them become the lines connecting them all together. But look, you don't build a massive web like this just to look at it. You build it to analyze it. And that's where specialized models called graph neural networks, or GNNs, come in. They are designed specifically to crawl through this graph and uncover these deep, complex patterns and relationships that would be totally invisible to any other kind of analysis. Okay, when you start building systems with this kind of scale and power, you're forced to hit pause and confront some really critical questions about the bigger picture, about data, about privacy, and about where AI itself is headed. 3 key frontiers are really emerging here. First, there's synthetic data, using AI to generate massive, realistic data sets to train these models. This can speed up development like crazy, and it can also help reduce the biases that you often find in real-world data. Second, there's privacy preservation. As the data gets more personal, tech like encrypted embeddings and federated learning becomes absolutely crucial. And finally, we have the next wave of true multimodal AI. Single, unified models that can natively understand and reason across all these data types at once, basically breaking down the final walls between text, images, and biometrics. So, when you combine these multimodal embeddings, the high-speed vector search, the real-time analytics, and this graph-based understanding, what do you actually end up with? Where does all this lead? It leads to this identity systems that aren't rigid and stuck in their own little boxes anymore. They become fluid, flexible. They're capable of doing things like a cross-modal search. Imagine searching for a face just by typing a text description of it, and reasoning about identity in a deeply contextual way that we've just never seen before. This powerful architecture is really just the foundation. The next logical step is to explore the systems that will be built on top of it, and to really understand the profound, real-world impact they are going to have.